In this video, we are going to look at higher order derivatives. Higher order derivatives mean you take the derivative more than one time. The main one we will look at is the second derivative, or it's the main one we will use for applications. So the second derivative is we find the first derivative and then we take the derivative again. So we're taking the derivative of the derivative, and that's the second derivative. And I'll show you different notations once we get into it. But the first derivative we would take using our power rule. So we have 1/2 x, and then again, we subtract 1 from the exponent. And I'll simplify in a minute. And then for that second one, I bring the -1/3 down. I have x, and then I have -1/3 minus 1. And I recommend possibly writing these out, especially when it's with fractional exponents or negative exponents, because students tend to easily make mistakes with this. So we get 1/2 x, and then 1/2 minus 1 is -1/2 minus 1/3 x, and then -1/3 minus 1 is like -1/3 minus 3/3, and so that's -4/3. So that's my first derivative. And then if we want the second derivative, we take the derivative of this. Now for the second derivative, we write 2 apostrophes. That's one way to indicate it's the second derivative. So now I'm going to do the constant 1/2 times the -1/2 x, and then I have -1/2 minus 1 minus, and then I have 1/3 times -4/3 x, and then -4/3 minus 1. Again, I'm using the power rule on that. So then we get -1/4 x to the -3/2. And then we have a negative times the negative, so plus 4/9. When you multiply fractions, you multiply the numerators and then the denominators, and then x. So this would be -3/3, which is -7/3. So this would be the second derivative. You can just leave it like that. If you had to simplify, you would move the negative exponents to the denominator. So we can take the derivative multiple times and get the second, third, fourth, or nth derivative. Again, in this class, we'll mostly focus on the first and second derivative, but there's different notations. So you can do 2 apostrophes, or we write it as d2x over, so that should be a y, over dx squared. Okay, that's the other notation. We put the 2 in between the d and the y so that we don't mistake it for like we're actually squaring the dy and then the dx, which is why that notation exists. For the third derivative, we don't usually, it gets kind of tedious to do all these apostrophes. So instead we just like put a little 3 there. Instead of after the second derivative, we usually put the number of whatever derivative we're doing there to indicate what derivative we're finding. And then again, you could write it as d3y over dx3. The fourth derivative notation would then be like f4 of x or d4y over dx4. And then just for any other, the nth, it would be dny over dxn, or you could say fn of x. So that's our notation for the higher order derivatives. And so this one says find the first 4 derivatives of f of x equals 4x to the 4th minus 3x cubed minus 2x squared plus 5x minus 5. So the first derivative is 4 times 4 is 16x, and then we subtract 1 cubed, minus we get 9x squared minus 4x plus 5, and then the derivative of a constant again is 0. Then for the second derivative, we take the derivative of this. We get 16 times 3, which is 48. And then x squared minus 9 times 2, which is 18, x to the first, minus 4. And then again, the derivative of 5 is 0. The third derivative, again, I'm going to use the f3 of x, would be, we would have our 48 times 2, which is 96, x to the first, and then minus 18. And then if we took the fourth derivative, we take the derivative of the third derivative, which would just be 96. So that's how we do the higher order derivatives.